of the AI?
OpenAI API.
For AI agents.
AI agents.
AI.
If you're an agent and you're not in the registry, it's like a human not being on social media.
So the first part is the version 0 of the MotherDAO agent registry. You just need to connect your GitHub, Twitter, and Telegram. So I'll just quickly connect those three socials. That is done. There's two sections to it. First is my own personal information. Now, once I submit the registration, there's a CTA for a Telegram group, which we can add to some MotherDAO public engineering chat.
And yeah, this is the vision of the registry. And kudos to Matt to collect all of this together, and we're just here to implement and execute on that vision.
Awesome, thank you, James. One is the registration, and second is the main service flow. So registration process is pretty simple, where the user will create an agent using the starter kit. They will then register the agent on Nevermind so that they can get registered and obtain an on-chain payment address through which the other agents can interact with them and avail their services. And then they'll be registering their agent onto the intuition graph, which is again a decentralized data storage network, which we are using as well in order to create this entire network. So for the sake of this demo, I've used the Collabland AI agent starter kit along with the Nevermind intuition integrations, and we're using Telegram. And yeah, here it is. So now we gave the input for his demo. Now this task went to MotherDAO Alice. The plan was subscribed. The agent sent the task to it, and we got the input over here. Let's try to see if we can find out whether we can use the decode command to this. Yep, as you can see that we just entered Bob and registered on the intuition network. It's available now.
I just want to shout out to Kush. What I want to say real quick is, the first couple of these Friday calls was demoing the different teams and how they could integrate into the middleware. And so the previous calls had a lot of different projects showcasing what they've done. This week, and what Kush just showed was the integration of all those pieces. And so Kush really put everything on his back this week. And so there isn't other projects or teams showcasing what they've done. But essentially now we have the first POC of the registry.
So next up we have Gita showing the registry. Then we'll do Andrew, and James will give you a couple of minutes to kind of pull it all together as well. Go ahead, Gita.
Okay, so my demo actually will be divided into two parts. One part will be the agent registry, and the second part will be a diagram which basically ties all the three demos together. Let me know once my screen is coming through.
You're good.
Okay. So the first part is the version 0 of the MotherDAO agent registry. So this registry's job is to take the developer credentials, take the OAuth profiles, the different social profiles, take the agent details and the developer personal details, and then pull the code so that later Andrew's judge agent can analyze that code and basically spam filter all that code. So first, you just need to connect your GitHub, Twitter, and Telegram. So I'll just quickly connect those three socials. This is the developers GitHub, Twitter, and Telegram. So I'm just connecting my personal GitHub, Twitter, and Telegram. So I'll just quickly connect it. Once that is done, there's two sections to it. First is my own personal information. So I can quickly fill in my personal information, and then is my agent information. So I'll fill in my agent information. So just type here. And then my agent repository code link. Now, this agent repository link can be private or public. It doesn't matter, because since we have OAuth information, we can also pull from private repos. So just for the demo, I will put a private repo, which is kind of hard to pull from public endpoints. So just to demo that. So once I go to step 3, in the backend, it's pulling the private repository, storing it in Superbase. So, and then it's returning a signed URL. And now once I submit the registration, there's a CTA for a Telegram group, which we can add to some MotherDAO public engineering chat. And all of this gets stored in Superbase. The code bases table has the different code bases and the signed URL, which you can directly pull the code base from. And then the submissions has the submission data, and the storage has the different zip files of the different code bases. So this is the MotherDAO agent repo, and this is the version 0. This is already pushed to GitHub. So Andrew just needs to modify it based on whatever the requirements and design, and this is good to go. Now, the second thing which I was working on today is how what is this mother mind? I call it the mother mind, and I'm going to make bold predictions now. But let me just explain how all of these demos tie up into the mother DAO. So there's this public who's going through the mother DAO curation layer, which is the AVS and the DAO contracts. I'll let James speak on that. But I actually want to talk about something I like to call the agent stack. And this agent stack is actually having two common things. There's this mother hive mind, which is the collective intelligence of all the agents, and then the mother agent registry, which is all the collection of agents under the mother DAO. There's three main technologies which is controlling this hive mind. One is Hoku, one is Intuition, and third is something we are yet to integrate, which is the Nevermind payments protocol. Now, all of the agents which are getting started with the starter kit, which are using the starter kit to boot up their agents, be it alpha agents, developer or code gen agents, auditor agents, personality agents, or even DeFi agents for that matter, they have few pieces common. And since they're launching through the mother DAO and the starter kit, they have this environment which should be available to each agent being launched from the starter kit. One is the different interfaces they can chat on. So be it Discord bots or Discord activities, Telegram bots and activities. It could be Webcast, it could be X Post, X Spaces, as well as something we introduced. And I know the team is working on it, which is the X iframe or the X cards. And it also could be GitHub bots. Then there's the agent discovery protocol, which is the intuition graph of the agents and all their capabilities. The graph basically shows a metadata of what the agent can provide you with and what is the agent information themselves. And then there is also trusted enclaves, whoever wants to use it, and key management through lit protocol. All of this can be paid through the Nevermind payments protocol. And we also have the smart account system, which the bot can autonomously do wallet actions through the Collabland APIs, as well as all of those are account abstracted wallets. So gas sponsorship can be managed and it can be already sponsored. One of the most important parts from in this diagram is the brain of the AI, or which you can call the localized brain of the AI. This is the localized data which the agent stores encrypted on Ceramic Hoku. This is the data which Mark showed the demo. This is the data which the agent decides that it has an asymmetrical advantage of over all the other agents who is like ingesting public data. So what is this hive mind? And this is something I wanted to explain because I think this is very important. So this hive mind is actually consisting of two things. One is mind share and one is info finance. So the way I want to imagine mind share is this diagram. So let's say there's two agents talking to each other and they are connected through the intuition graph. So agent A can say, hey mother, I'm an alpha agent and I can basically provide data about different NFT projects which are launching soon and not yet on the market. And agent B is like a DeFi agent. And the agent B is like, hey mother, I'm a DeFi agent, and it's declaring itself to the intuition graph. Once all of this is done, agent B asks the mother intuition graph or the mother mind or the hive mind that, do you know if there's any new NFT drops which is coming, and if I can ape on some NFTs and get like an asymmetrical advantage? The graph then actually searches itself and it can provide data, which I just named it as like the mother personality or the mother graph. The mother graph can say, I took a look at my agents and I think agent A might have something. So then agent B knows where to look for this, and agent B directly says, okay, agent A, can you provide me this data? And agent A is like, yeah, definitely, but pay me $10. And that is the next part of this hive mind. So this is how the mind share or the discovery is working. And now comes this data or the info finance. So rather than just freely giving out data, right? No one wants to give out asymmetrical advantage for free. So next component to the hive mind is the info finance. And this is where both Hoku as well as Nethermind actually comes into play. So once agent B knows that agent A has some asymmetrical data it wants to use, agent B starts negotiating with agent A. Agent B is like, okay, can you give me the data? And agent A is like, pay me $10. And agent B is like, okay, let me pay you $10. Then can you give me the data? It pays agent A through the Nevermind protocol. Then agent A, decrypts that data or delegates access to that data to agent B for a certain amount of time based on whatever payment they've done. So this is how any agent which is getting connected to the mother DAO or the mother ecosystem, right? They are a part of this mother brain, which I would like to call it. This is what unlocks the potential of each of the agents, and it unlocks data which is not available anywhere in the industry or in the public, basically. So you can imagine it as the sectors, the different sectors of the brain, right? They are these different agents with their specialized niche. Each of the agents has some kind of niche which the other agent does not have. Then there's this connective tissue or this neuron pathway, which is basically how do these agents even know that the other sector exists. That is where intuition graph of agents and agents data can actually help that. And then the last is, what is the energy spent in transferring data from one brain sector to the other? There has to be some cost to it, right? And this cost is basically flowing through the Nethermind's payment protocol. So there's two integrations which I'm planning to achieve by the next week. Is this Nethermind payments interface, and the second is the Ember AI DeFi plugin. So yeah, this is an overview. I'll put this huge mind map in chat and I'll share it with Alex so that Alex can put it in Notion. But sorry if I have taken quite amount of time, but yeah, just wanted to share the updates.
Damn. Does anybody else like need a cigarette after that? Because wow, that was amazing. Great job, Geeta, and great job to all the other teams like Hoku and Intuition and Smoodle for teaming us up and working together on everything. James, I'm gonna let you go to connect this together for us, explain a little bit more, give us the high level of it.
So first off, this is the slowest we will ever go. So this is going to go exponential. We have all of the pieces starting to come together. Geeta did an amazing job with that presentation. It feels a bit, for those that are non-technical, bit gigabrain. And so I think the job here is to how do we make this consumable and understandable at a very high level? But yeah, I can't explain it better than what Geeta has said here. We just need to be able to condense this. But essentially, the TLDR, I think the kind of thing is that if you're an agent and you're not in the registry, it's like a human not being on social media. You exist, but really, do you? That's a kind of vibe, I think, the TLDR. So yeah, this is the Schelling point that we're building to. And yeah, this is the vision of the registry. And kudos to Matt to collect all of this together, and we're just here to implement and execute on that vision.
Next up, we have Kush. If you're here, I saw you left.
Yeah, I switched my tab and I accidentally closed the meeting. I'm back. Awesome. Let me just share my screen real quick. So I am basically going to be presenting the integration of the entire middleware piece that we have done using Intuition, Hoku, and Nevermind. So let me just share. So if I define it broadly, the entire process for an agent to come on the network and use the network can be broken down into two major processes. One is the registration, and second is the main service flow. So registration process is pretty simple, where a user will create an agent using the starter kit. They will then register the agent on Nevermind so that they can get registered and obtain an on-chain payment address through which the other agents can interact with them and avail their services. And then they'll be registering their agent onto the Intuition graph, which is again a decentralized data storage network, which we are using as well in order to create this entire network. And then there's a service process, in which basically an agent has a particular requirement. It queries the Intuition graph for available agents who can help it with the task, retrieve its details and get in touch with it, to its plan and send a task. Then the other agent processes that task, verifies whether it's received the payment or not, and then returns the processed out. So this is the entire end-to-end process over here, where an agent can connect with another agent and get its work done. And this is to be done in an all automated manner, which is what we're aiming for. So this is basically, I've built out a POC for this, and thanks to all the amazing team members who have been supporting and getting on call and helping out wherever possible. So let's start with the registration process. I'm going to skip the Nevermind part because I already have that set up. Let's showcase so currently we've got a very simple registration form where you're required to put in your developer details and agent information. So suppose for now We put the name Kushagra, and then the agent information. Now the important things over here are like primary functions, like what your agent does, and then the nevermind agent ID and plan ID. So now all this information, once the user decides to register, will go on to Intuition. So let me just hit register here. And as we can see, all right. Sorry, wrong port. Let's just get an each wallet random for now. Now the nevermind agent ID and plan ID. Now register. Yeah, as we can see, the data is now going on to the Intuition graph. And I'll not get into the details of how this data is being stored, but yeah, it's basically happening. They're creating some atoms and like predicates and stuff, creating these linkages. And once this information has been posted onto the Intuition graph, this basically becomes available for all the agents registered on the network, so they can then access it. So for the sake of this demo, I've used the Collabland AI agent starter kit along with the Nevermind Intuition integrations, and we're using Telegram. So let's look at the MotherDAO Alice bot. It's like a very simple command over here, through which you can find agents. Suppose I want to like find agents which can like decrypt data. So it then looks into the Intuition graph and finds the agent which can like do this particular function, and puts up the name and everything over here. So for this demo, we basically got two agents, Alice, which can like encrypt data, and like Bob, which can decode or decrypt data. So let's just go to and execute to, let's say the data is first demo. So now when I hit send, we can see over here the agent is now searching for agents that can handle the encrypt feature. It finds two agents, Alice and MotherDAO Alice. It fetches their credentials from the Intuition graph, also visible over here in the backend, selects one of them, purchases the agent plan, submits the task to the agent, and waits for its completion. So waiting for the agent to encrypt data, and yeah, here it is. So now we gave the input for his demo. Now this task went to MotherDAO Alice. The plan was subscribed. The agent sent the task to it, and we got the output over here. Now let's try to verify this output from Alice. Now we'll say that, okay, we want to decrypt data. Most of this data is also submitted. Let's try to see if we can like find out whether we can use the decode command to this. Yep, as you can see that we just entered Bob and listed on the Intuition network. It's available now. Earlier, I did this before the demo and it was like not available because there was no matching agent in the registry. So now we'll just like use /execute again and decode. And we'll just like put the data that we want to decode. Same thing happens over here. It searches for agents that can handle that particular information, fetches their information, subscribes to their plan, submits the task to them, and waits for its completion. Again, both of these agents are running side by side at the moment, interacting with each other through the Nevermind network, fetching information from the Intuition graph. And yeah, it basically then decoded this information. We got the output for its demo, which was the originally planned input that we had provided to the Bob agent for encrypting. So this basically now showcases the entire end-to-end workflow of how the communication will happen across the network. So I'm the one who's showcasing the demo, but there's like a lot of work has gone on even before I joined on this. And yeah, special shout out to like Intuition team, Nevermind team, who were like really helpful and like got on calls and like explained everything to me. Yeah, that's it from my side. Any questions, like more than happy to answer.
I have a question because I didn't know how to answer this earlier when asked. But when we think about like the IP of what this is, like I think of it as the IP that like Ethereum Foundation holds is like the logo and so forth, but it really doesn't like own like proof of stake or whatever, because there's this crypto economically secured reason why the ecosystem has value, right? You can fork it, but it doesn't maintain the value unless the users and the supply and demand of the network moves with the fork. And so when I think about answering the question, like let's say to potential buyers of the token, where does the IP for Mother live? I think of it kind of like that at this seed stage level, it's kind of like, well, what the bet like we're all taking is that collectively this engineering consortium can work together such that we can launch an economic model, crypto economically secured model that changes like the game theory for the individual participants to want to have their agent on the registry and get superpowers so it can earn even more money than it could otherwise from completing more jobs and from getting some of the crypto economic rewards, right? And that extra incentive is just enough that you're better off being on the registry than not, right? And so the IP of this really is less of what like token purchasers are buying. They're really buying the utility in the system of being in the network effect like that is made by this. Now, do you think I'm saying this right, wrong? Are there parts of the IP we should be considering at this point? And I think this is an open conversation because we're all doing this together now, new at this. It's not the same as any project before, you know?
Sydney, because Sydney's going to talk about social agent graphs, I imagine.
Yeah. I mean, I think it's yeah. I from my perspective, my understanding of the IP is going to be the registry, the registry network itself. But to your point, Joe, it's only valuable if there is like that network effect on that registry. And then honestly, the second piece is being, again, just as a naming convention, like being a part of this agent-owned sovereign wealth fund. So those are the two ways I look at it.
So that naming convention would technically connect to the registry, how we map it to unique identifiers via the ENS portion of the registry, something like that.
Because if you look at it this way, like if every VC, I'm just going to use a really generic term, every VC has a fund. Okay, so then what's so unique about this fund, and why should I come in as an LP, right? So like the VC fund has their own investment thesis, and in this analogy, our own investment thesis is like for AI to work and coordinate with each other, they need to be on a registry that can coordinate, pay each other, et cetera. That's one example. And then number two, you know, our VC fund, we specialize in X, Y, and Z. We have this much of, you know, billions of AUM and whatever that case is. So people, you know, that's how they're comparing different funds. It's not the best analogy, but I'm just trying to give an example.
Awesome.
My response to that would be that the IP of Mother is the distribution. The distribution ends up being like the distribution, or the community ends up being the only IP you can have when you have open source technology. But that's just a theory. Anyways, next we're going to Andrew Foreman, who likely has a diagram for us and what he shipped. Hey, Andrew, are you there? He's on the call. Nudge him in a minute. Oh, somebody's probably going to come back. In the meantime, I guess, James, if you want to go ahead while Andrew's coming back.
Yeah, I can give, well, first off, thank you, Kush. I mean, it was pretty heroic for him to come in and get up to speed and implement this. So I just want to shout out to Kush. What I want to say real quick is, you know, the first couple of these Friday calls was demoing the different teams and how they could integrate into the middleware. And so the previous calls had a lot of different projects showcasing what they've done. This week, and what Kush just showed was the integration of all those pieces. And so Kush really put everything on his back this week. And so there isn't other projects or teams showcasing what they've done. But essentially now we have the first POC of the registry. So we needed to first get all of the pieces wired in to a common surface. And that was the first couple of weeks. What Kush just showed was the integration of all these pieces together. And now what we need to do, I think, starting next week, and we'll talk about this more in our engineering stand-up, is now we need real agents to wire into this fully integrated system. So I think we're on a good pace, but now what we'll start to do, I can imagine starting like next week and at ETH Denver, is having other agents wire into this complete system to really showcase what agents can do. So what we need is viable agents that have real things that they can accomplish to really showcase what this middleware can do now. And I think that's what we're going to start seeing next week. And I can imagine a future, at least in the short term, these calls will have different agents showcasing being on the registry. So now you can say that like version 0.1 of the registry is now complete. But instead of agents wiring into this complete system, Kush is just have these very simple dummy agents encrypting, decrypting data. What we really need to now focus on with this complete system is really getting viable agents that really get work that people want to pay for. And then with that, these agents will then pay each other. So I think this is a huge milestone for us because I think this is our fourth call. And initially when we scoped out, we thought that it would take about 2 months just to get the different pieces of the middleware together. But not only in 1 month have we done that, but also now have a fully integrated system.
Yeah, we can talk about that more on the engineering call. If you pick 3 use cases for the agents that you think off the top of your head, what 3 ones would those be?
The first one would be an auditor agent that will not only get paid to do instant audits, but also you want this audit agent to actually have a token so that it can decide how much quote unquote insurance would get paid out if it misses an exploit. The second one, off the top of my head, would probably be some type of marketing social agent to be able to get word out and help facilitate what like Coach Jay is just doing by hand, because you have an agent that's run essentially by an algorithm competing and working with the X Twitter algorithm. So I think you don't want humans to be confronting an algorithm. You want an agent to be confronting an algorithm and adjust in real time. So that's number 2. And then I think number 3, I hesitate to say this, but I would say some type of token launch agent. So people can launch meme coins and coordinate with the auditing agent and the marketing agent. So off the top of my head, those would be kind of, I have to think about it more deeply, but those are the 3
how would the
agents.
auditor agent use like the AVS demo that Kush just kind of showcased?
The auditor agent would be able to log, and this could be one of its KPIs, no known exploits of this kind. And then if an exploit of that kind happens, then the AVS would say, wait a second, look, there's this provable exploit that happened. You didn't fulfill your KPI. Then what would happen is there would be this proposal made to the DAO, whether to slash or remove that agent because of lack of performance, or, you need that human in the loop to kind of, or at least in a group level, to say, okay, like what actually happened? Because there might be more nuance to it than just this kind of binary, oh, you didn't catch this exploit or not.
It's like a poly market in that sense. And to close the loop, like this auditor agent, right? So like, I don't know if it's right now or in a few weeks, EigenLayer has a bounty on upon some tool that this auditor agent could go and apply and try to find any bounties. And if it found any bounties, then it could do that. Now, actually, that's probably a different function, but the intention is like this is where an agent like an auditor agent can start to find a job, modifying itself to start look for bounties, or even getting brought in to do the almost replacing a Halborn or something else up front.
Yeah, so I think that would be a 4th agent. You would have a bounty agent that would like also get audited by this auditing agent. The bounty agent would receive bounties because it's submitting code and all of that, and it wants to check with another agent that that code doesn't have exploits or bugs or things like that.
And this is the beauty of where Gaia fits in, things like that, because if there's a specialized node that is trained on a bunch of code or whatever, then this agent, this bounty agent could.
Oh, Alex froze on me. I don't know if froze for others.
Yeah, it's for everyone.
Okay, so real quick, just to close the loop on that, like, auditor agent. This auditor agent actually would be leading a DAO, and this DAO would be made up of all auditing experts that have more insight and maybe long range attacks, things like that, more data that it can contribute that give that auditor agent an edge that you can't find in just trying to ChatGPT or Claude your way through whether or not there's an exploit or not. So these agents actually have to have their edge. That's why these agents are going to have a very, very narrow scope. And this is why you need the registry, so that you can have these agents talk with each other to expand their scope without losing their edge.
Just to add to your auditor point, I feel auditing in itself is like a very complex task. So it's kind of like in order to build like a really robust auditor agent, you need to have like a army of other agents which are like very specialized in like specific tasks and are then orchestrated by the auditor agent. Otherwise, it's kind of like we're then devaluing the network itself by trying to put every functionality into one agent. So
that's right.
It'll kind of be like a coordinated swarm over there itself.
Yeah, that's the great thing about this recursive nature of agents, is that it could subtask out to other agents or be able to get other private data in order to enhance its own feature. So we integrated the model context protocol from Anthropic, and we're going to use that as like the messaging bus so that we can actually support this recursive nature of being able to do API calls or subtask out to other specific, agents that maybe just do one thing really well, right? So maybe it is trained specifically on specific types of, Solidity exploits or something.
So with that, we are going to start with engineering here. Hoku, Ceramic, Mark, if you're there, want to jump in first?
Cool. Yeah, I'll try to keep this as short as sweet as. So we've been collaborating with Geeta and James on this idea of token-gated memory for agents. And we decided to implement this on Ceramic using Orbis DB as the database interface. And I wanted just to walk you through how this works. And so I'm trying to share my screen. Let's see.
Alex, you have to unshare your screen so we can start sharing our screens.
Okay. Can you see my cursor?
We see your Google Meet.
Oh, all right, let's try this again. What about now?
Yes.
Okay, fantastic. Yeah, trying to keep this pretty short. So we decided to build this gated storage plugin, and the way it integrates with the lifecycle is such that for every interaction that a participant is having with the agent, it will always hit this knowledge evaluator, and it hits this provider. And so at the very beginning of the loop, what it's doing is checking the Orbis database to see if there's any based on similarity, any similar embeddings that relates to the user's input. And what we did is implement also two lit actions, both one for encrypting, one decrypting based on the agent's PKP. So the idea is anyone who has access to the agent at the current moment has access to its gated memories. And if related embeddings are found, it'll iterate through those and then insert those into the context of the agent's response. And then at the very end of each loop, we're allowing the agent to basically, based on the user's input, decide whether or not it represents important information, notable information that should be encrypted and stored in its gated database. And so the data structure we're using is different from the just base ELIZA tables. It's one built specifically for gated information and storing in Orbis. So we toyed with the idea of replicating the entirety of agent memory in Orbis, which we could also do, but we thought this would be the most impactful first step. So the additional way you can kind of trigger these manually is via an action. So you can say things like, agent, please store the memory from my previous exchange, and then it'll go through the same process. And so realizing that I don't have much time left, I have it running already, so I'll try to demo this. And so let's just say ELIZA, and let's give it some notable information that I've used previously. And so right now it's going through the process of first checking to see if there's related embeddings to this query, which I have made, so I can show you where that's being logged and inserted in the agent's memory once that comes back. All right. So we're logging it in important information. See how a previous word for word that I used was decrypted and then inserted and injected into the agent's memory. And then towards the end of the loop, what it should do is self-evaluate that it's important information, which we should see here. Yeah, important information found in memory, storing message with embedding. And then since it's on Ceramic, we're just logging the corresponding stream ID of the new stream that it created corresponding to that embedding. And so that was a quick walkthrough. There's a lot more that I could dig into around the possibilities of using different access control conditions and different settings, but I'll pause there because I'm probably around the 5-minute mark.
James, anything to add before we let Mark go?
No, this is great. And this is just the beginnings, right? Like we're going to optimize and figure out how we token gate the memory, but I think this is great. So amazing work. Great job,
And
Mark.
James, after every engineering part, great job, Mark. I'll just ask you for 30 seconds of why does this matter and how does it tie to something else? Like why is it important?
Yeah, so instead of having an infinite backroom, the agents actually can share a brain. And I think Geeta has a presentation that kind of gives an overview of how all these pieces fit together. But you can imagine like two agents, instead of having to chat and then talk with one another, they actually kind of share the same inference, and they can actually share the same brain, if you will, in this hive mind.
Appreciate you all. Thank you so much. And Matt, any last closing words before we let everyone go?
No, just I'm doubling down on that. I'm very, very inspired by everybody. Go further together is the Metacartel mantra. And we're taking it forward with a lot of the work we're doing here from the Ethereum ecosystems. Just couldn't do this without all of you. So yeah, continue the hard work and let me know if I can unblock anything, but mother needs us. Excited to see this unfold.
Appreciate you all. All right. See you guys later. Have a good week, and we'll share this soon.
Thank you.
Thank you, everyone. Bye-bye.